Hey everybody, in this video we're going to talk about section 1.10. We're going to continue our study of the equations of lines. So we already learned about slope, and so I'm going to go over the different ways that we can write the equation of a line. So we can write the equation of a line using the point slope form. So which in this case means that in order to find the equation of a line, we need the slope and 1 point. And so the point slope form looks like y minus y1 equals mx minus x1, where the slope is m and the point is x1, y1. So if you have a point and you have the slope, we can use the point slope form. Another way that we can write the equation of a line is using the slope-intercept form. So in this case, we need the slope, m, and we need the y-intercept. And the y-intercept is usually the point 0, comma, b. And so you'll see the equation when it's in slope-intercept form, you'll see it as y equals mx plus b. So you're able to tell the slope, and the y-intercept is the point 0, b. So if you're, usually for me, when people say, what is the y-intercept, I want to think of it as a coordinate pair, 0, b. So if you just say b, you're just given the y-coordinate of the y-intercept, but you're not given the y-intercept itself. The y-intercept itself is a point, so you have to write it in terms of with the x-coordinate and the y-coordinate. Now, standard form of the equation of a line is something like ax plus by equals c. And where a, b, and c are integers, so no fractions, and a is usually positive. So an example of this would be something like 2x minus 3y equals 9. So this is an example of an equation in standard form. But if you have something like 1/2 x plus y equals 4, this is not in standard form. Why not? Because 1/2 is not an integer. So you will have to then clear the fractions or multiply everything by 2 to get rid of the fraction, and then you will have it in standard form. And if this was negative, then that wouldn't be in standard form either. The a has to be positive. It doesn't have to, but most books define it as the a is positive when you have it in standard form. So that's what, those are the three ways to describe a line. You can do it in point slope form, slope-intercept form, standard form. The ones that are useful in finding the equation of a line are point slope form and slope-intercept form. So these are the ones, that are useful in finding the equation of a line. Once you find the equation of a line, you can write it in y equals mx plus b form, so the slope-intercept form, or you can write it in standard form. But to find the actual equation of a line, these are the ones that you need, because to find the equation of a line, we need the slope and at least 1 point. So what does at least 1 point mean? Well, we can then use the point slope form to find it if I have a point. So let's try an example. Here we want to find an equation of the line that passes through the points -1, 2, and 4, 3. So notice above I said to find the equation of a line, we need the slope and at least 1 point. Are we given the slope? No. And this is when we are not given the slope. This is why the second one comes in handy, at least 1 point. I have 2 points. Given 2 points, I can find the slope of a line. So let's find the slope. So to find the slope, we need to know the formula for the slope of a line. So the slope is rise over run, or it's better to know the formula y2 minus y1 over x2 minus x1, the change in y over the change in x. So it doesn't matter which point you start with as long as you're consistent. So I'm going to start with the first one, calling this x1 and y1. So my slope is going to look like y1 minus y2, so it'll be -2 minus 3 divided by So that was the change in y divided by the change in x. So since I started with -2, I'm going to start with -1. So -1 minus 4. And so notice that I end up with -5 on the top and -5 on the bottom. -5 divided by -5 is +1. So that's my slope. Now just to illustrate why you get the same thing, if you did it the other way around, if I use my other point, it will be 3 minus a -2. So I can say 3 minus a -2 over, so since I started with 3 on the y, I have to start with 4 on the x. So that's what I mean by being consistent. Whichever point you start with, if I start with this y value, I need to start with that x value. Here I'm starting with this y value, so I need to start with that x value. So 4 minus a -1. And so 3 minus a minus, that becomes a plus. So 3 plus 2 is 5. And 4 minus a minus becomes a plus again. Plus 1 is 5. And I still get +1. So regardless of which way I do it, the slope is the same. And so now that we have the slope, we can use any of the points. So I know the slope is 1, and my point is going to be, I'm going to pick the one with the positives. It's just less room to make an error if I'm not using the negatives. And we can use the point slope form. So I'm going to use y minus y1 equals mx minus x1. So this is going to look like y minus 3 equals the slope, which is 1, times x minus the x value, which is 4. So this is my x1 and my y1. And solve. So I'm going to have y minus 3 equals just x minus 4. Add 3 to both sides, so y equals x minus 4 plus 3 gives me -1. So this will be my equation of the line. This is in slope-intercept form. So now I can gather some information from here. I know the slope is 1, but I already knew that. But now I also know that the y-intercept is the point 0, b is -1, so 0, -1. If you want to use, so this is using the point slope form. What if we wanted to do it using the slope-intercept form? So using slope-intercept form, we will be using y equals mx plus b. So still, I need the slope and I need a point. So we know from up here, I'm going to use the same data. M is 1 and the point is 4, 3. So now, though, these are just, I don't have x1, y1. This is just x is 4 and y is 3. So when I put it in here, this is going to look like y, so 3 is equal to m, which is 1, times x, which is 4, plus b. So m is 1 and x is 4. And so with the slope-intercept form, we are solving for b. And so when I solve for b, so this is what 3 equals 4 times 1 is 4 plus b. And then move the 4 over, so -4 from both sides. And you end up with -1 is equal to b. And so now we put it into the y equals mx plus b form. Now that we have b, so I will have y equals the slope is 1, so just 1x, so it's just x, and b is -1. And so this will be the equation of my line, which notice they are the same thing. So those are the two ways of finding the equation of a line. And now if I want to write it in standard form, standard form means the x and the y's are on the same side. So I will have y equals x minus 1, bring the x over. How do I bring the x over? And just subtract it. So I'll have minus x plus y equals -1. But my x, the coefficient of the x is negative, and I want it to be positive. Remember, we said that to be in standard form, a, b, and c are integers, and a is positive. So I need that -1 to not be negative. So we will multiply both sides by -1 to make it positive, to make that coefficient positive. So distribute the -1. So I'm going to have negative times a negative is positive. So x minus y equals 1. So this will be the equation of the same line in standard form. Okay, let's try another example. So this one, find an equation of the line that passes through the points 1, 7, and -5, 3. I'm doing the ones that have 2 points because if you're given the slope, you just kind of plug it into the either equation. And I'm never going to ask you to do one method or the other. It will be up to you to use either the point-slope form or the slope-intercept form. Just to give you a heads up though, when you get to calculus, the point-slope y minus y1 equals mx minus x1 is the most widely used. So if you are headed towards Calc 1 in that route, then you might want to get used to using this form rather than y equals mx plus b. Okay, so for this example, find the equation of the line that passes through these 2 points. Same thing, we don't have the slope, so I need the 2 points to find the slope. So the slope is y2 minus y1 over x2 minus x1. And I'm going to start with the second one this time. So 3 minus 7 divided by, since I started with 3 for the y, I have to start with -5 for the x. So -5 minus 1. So 3 minus 7, what's that? -4. And -5 minus 1 is -6. So negative divided by negative is positive. And for 6's, we can reduce by 2's. So reduce it by 2, and we're left with 2/3. So that's our slope. And now, because we have 2 points, we have freedom of choosing whichever point we want. Again, I am going to choose the point 1, 7, just because less room for error if I don't choose the one with the negative. Sometimes both points have negatives, and so you're out of luck. But I just know myself that I can sometimes easily forget a negative or like make the little oversight of seeing that a negative times a positive is a negative, or negatives just bring me too much room for error for me. So if I have the option of not using a negative, I'm going to take it. So now we're going to use so I have the slope as 2/3, and I'm going to use the point 1, 7. And so now I have the option. Do I use the point slope form, y minus y1 equals mx minus x1, or do you use y equals mx plus b? Use whatever you're most comfortable with. I'm going to use the point slope form. So this is going to look like y minus my point. So this will be my x1 and my y1. So y minus 7 equals the slope, which is 2/3 times x minus the x value, which is 1. And now we solve. So the point of these problems is to try to simplify it and put it either in y equals mx plus b form at the end or in standard form. So we're going to go for standard form in this one. So y minus 7 equals, distribute the 2/3. So I get 2/3 x minus 2/3. And now add the 7. So we want to get the y all by itself. So I'm going to add 7 to both sides. Technically, these are like terms, so I could have lined them up. I don't know why I didn't. So just bear with me here. So I'm going to have y equals 2/3 x minus 2/3 plus 7. So I have a fraction and a whole number. So I'm going to put a 1 underneath that 7 so that I can get a common denominator. What's our common denominator? 3. So I'm going to multiply top and bottom by 3 to get the common denominator. And so this is really y equals 2/3 x minus 2/3. 3 times 7 is 21, so plus 21 over 3. And now that they have the same denominator, you can combine them. So this will become y equals 2/3 x plus 19 over 3. And so this will be the equation of the line. Now this is in slope-intercept form. Which now, what can I get from here? I can get that the slope is 2/3. but we already knew that. And I can get the y-intercept. The y-intercept is the 0.019 thirds. So that will be, this will be a little bit hard to graph, but that is our y-intercept. Now if you want to write it in standard form, in standard form means we want to have the x and the y on the same side and no fractions. So far I have y equals 2/3 x plus 19 thirds. That's a funny looking number, 19 thirds. So let's make sure that I did my math correctly. Looks like we did it correctly. So sometimes when I see numbers like that, it kind of makes me worry a little bit. Did I do something wrong? But that's a time to go back and, okay, did I do everything correctly? Looks like I did. So get the x's on the same side with the y. So that means I'm going to subtract 2/3 x from both sides. So here it will go away. On the left side, I'm going to have negative 2/3 x plus y equals 19 thirds. Now remember, standard form means we can't have fractions and we can't have a negative. So I am going to do it all in one step. I'm going to multiply both sides by, I want to get rid of the negative and of the 3. So I'm going to multiply both sides by -3. And so when I multiply this, I get 2x minus 3y equals 19. Okay? Okay, let's try one more example before we talk about parallel and perpendicular lines. So I want to find an equation of the line through the point 1, -4 with undefined slope. So what does undefined slope mean? So depending on how well you know your lines, you may already know that undefined slope means you have a vertical line. But let's talk about that slope. So if the slope is undefined, that means that when we have the slope as rise over run, which one is 0? If rise is the change in y over the change in x. In order to get an undefined, that means that your slope would have had to be a number, so y2 minus y1 over 0. So to get undefined, that means that you have divided by 0, and that can't happen. So that means you do have a rise, but you don't have a run. And so that gives you a vertical line. So the way that I then will think about this is I'm going to go to the point 1, -4. So there's 1, not drawn to scale here, and then -1, -2, -3, -4. Plot the point, and because the slope is undefined, that means that the run is 0. So there's no movement of this line along horizontally. There's no left or right movement, only up and down. It does have a rise, so there's difference in the y's. So then my line is going to go along here. And so we can draw the line. And so, whoops. So this will be my line. Pretend that that's straight. And so what is the equation of this line? Well, it's staying the same at the same exact x value. So my point here is the point 1, -4. But if you look at the point here, what is this point? This is 1, 0. If you pick any other point in here, it's going to be 1 something. Let's say 1, 10. And so that's why there is a rise, because the y values are changing, but there's no run. The x values are changing. So the equation of this line will just be x equals 1. The x is staying constant. So x equals 1 is the equation of that line. And unfortunately, we can't use the y equals mx plus b or the point slope form because we can't, there's no slope. Slope is undefined. So this is one of those things that we just kind of have to know that when the slope is undefined, that means this is an x equals line. It's x equals whatever the x value of your point is. And I'm a visual person, and so that's why this is helpful to me, to kind of say, okay, I'm going to go to my point, and then what does the slope undefined mean? It means that the bottom is 0. In order to get undefined, you must have divided by 0, which means that then when you have rise over run, there is no run. Right? If the run is 0, that means it didn't move left to right, only up and down. And then I can draw the line and then see that, oh, this is a vertical line. If the slope was 0, so side note here, so if m was 0, then that means that when you have rise over run, then this will be 0 over x2 minus x1. So now there's no rise, there's only a run. So what kind of line is this going to be? Right now it's not moving up and down because there's no rise, but it does have a run. It's moving left to right. So this is going to be a horizontal line at whatever your y value is. Okay, so I'm going to record another video for perpendicular and parallel lines.